Welcome everyone to The Foundry by Forge College. I'm your host, and today we're tackling a massive, honestly game-changing milestone in your capstone journey. We are taking all your high-level strategic planning and drafting the ultimate foolproof engineering blueprint for your Solana deployment. Today's explainer is all about documenting the deployment process.
Okay, let's set the scene for a second. Imagine you're handing off a deployment. It's 2 a.m. You are absolutely exhausted, and suddenly, chaos. Keys are lost, a build is failing, and panicked slide messages are literally blowing up your phone. Why? Well, because you didn't write anything down. Deploying without a detailed map is just a guaranteed recipe for disaster, and as engineers, we want to eliminate that stress entirely.
To understand why this is so critical right now, let's just take a quick look at where we are in our curriculum journey. We're currently bridging the gap between the execution strategy you designed previously and the final assembly of your executable scripts, which is coming up in the next lesson. Basically, we are turning your raw ideas and task lists into a rock-solid operational document.
So here is the master schematic we're building today. It's a straightforward Markdown file covering 1. Scope and pre-flight checks, 2. Authoring the runbook, 3. Logging decisions and handoffs, 4. Validating the draft, and 5. Getting ready for final assembly.
Part 1. Scope and pre-flight checks. This is our pre-deployment foundation. Now, this really brilliantly illustrates the difference between just hoping for the best and enforcing a strict engineering standard. We've all been there, right? Relying on vague criteria like, I guess it works? But measurable success means explicitly stating something like, max response latency is less than 200 milliseconds for 95% of probes. You can actually test that. You can automate it. That is the standard we need.
And alongside that measurable scope, you absolutely need a pre-deployment checklist. You have to lock down your exact tooling, your target clusters, and required artifacts. No guessing allowed here. If a release engineer needs to approve the build, their name goes on this list in permanent ink before you even think about starting.
Moving on to Part 2, authoring the runbook, getting into our step-by-step actions.
So what exactly is a deployment runbook? Well, think of it as the step-by-step assembly manual for your project. Without it, you're definitely going to end up with leftover screws or, in Web3 terms, stranded tokens and broken smart contracts. It's a highly ordered manual of actions tied to verifiable checkpoints that just completely eliminates all ambiguity.
And here's the secret sauce. Every single step in your runbook must enforce 4 things: an owner, a clear action, an observable checkpoint, and strict acceptance criteria. So, if the release engineer runs a cargo build BPF action, the checkpoint is a green CI build, and the acceptance criteria is that the resulting hash strictly matches the release manifest. You never just run a command. You run it, verify it, and accept it based on hard data.
Part 3. Logging decisions and handoffs. Let's talk about records and transitions.
Enter the decision log.
Guys, a decision log is your absolute best friend during a future audit or, heaven forbid, an emergency rollback. It saves you from those endless, painful, why did we do this meetings 6 months down the line. It's simply a dated record stating a non-obvious choice you made, the alternatives you considered, the rationale, and who exactly made the call.
And when it comes to passing the baton, explicit handoffs with testable criteria prevent massive bottlenecks. A vague, confirm program is deployed helps literally no one. An explicit handoff says, verify program ID XXX in registry and probe returns 200. When you pass work to the QA or operations team, that next engineer needs to know exactly what done looks like so they can take over seamlessly.
Part 4, validating the draft. Time for automated and manual checks.
So your validation protocol actually involves both automation and human insight. First, you'll run a simple node script called validate.doc.js to ensure all your required Markdown headings are actually present. But listen, automated scripts don't replace human review. You still need to manually spot check the runbook's completeness and verify those handoffs are truly testable.
And what if you encounter ambiguous acceptance criteria or missing owners during that validation? Well, schedule a quick 15-minute alignment meeting with your stakeholders to fix it immediately. Seriously, a 15-minute chat now saves hours of painful, highly stressful debugging during the actual deployment window.
Part 5, ready for final assembly, preparing for our scripts.
I absolutely love this quote. Documentation makes the planned execution repeatable and auditable before final assembly. Just like the other amazing programs taught across Forge College's community, this principle emphasizes that true engineering is about repeatable, auditable success. We don't rely on luck. We rely on solid, thoroughly documented processes.
So, here are your concrete next steps. First, finalize your Markdown draft so all those validation checks pass. Second, commit it to your Git repository. And third, lock in your document by recording that version control commit hash right in your appendix. This gives you a perfectly traceable artifact, totally ready to be converted into executable scripts in our next lesson.
So I'll leave you with this one question. Is your deployment actually ready for the real world? Before you deploy, ensure your blueprint is absolutely flawless. This structured approach is exactly what separates amateurs from professionals in the Web3 space. And hey, to master more Web3 engineering strategies and explore our other learning tracks, make sure to visit forge.college. I've been your host. Thank you so much for joining me for this explainer, and I will see you next time.